back. In this video, we'll be looking at expanding binomial coefficients. We'll be looking at expanding brackets where the power of the bracket has either a negative value or a fraction or both. So let's see what's the difference from what we're learning today with what you already know. As you know already, we can write a binomial expansion of that bracket with such terms. So previously, when the n was an integer, or actually n was a natural number that you always had it to be positive number, using your calculator was enough to evaluate these blue terms here. You had no problem. But today, n is not going to be a natural number. Today, we'll see n to be a negative integer, that is a member of negative values. It can be negative, or it may be a fraction. You cannot put these coefficients on your calculator. You cannot evaluate, for example, half factorial over half factorial and half factorial. It, it just simply doesn't work. Factorials don't give you the answer straight away on your calculator. So half choose 2 or 2 choose a half doesn't make sense on your calculator. So we'll have to simplify things with learning some maths. What are we learning here? Let's learn to simplify those blue coefficients. So we previously learned in year 12 that n choose r, its definition is n factorial over n minus 1, n minus r factorial multiplied by r factorial in the denominator. So n choose 0, what is it? We know 0 factorial is 1. If you don't know why, just write the pattern for yourself. What's 5 factorial? 5 factorial is 4 factorial is 3 factorial, 2 factorial, 1 factorial, and finally 0 factorial. Alright, I'll give you a clue. 5 factorial is 5 factorial is 6 factorial divided by 6. Okay. 4 factorial is 5 factorial divided by 5, because that would be 5 times 4 factorial over 5. And 3 factorial is 4 factorial over 4. 2 factorial is 3 factorial divided by 3. Are you getting the pattern? 1 factorial is 2 factorial divided by 2. Therefore, 0 factorial is 1 factorial divided by 1. 1 factorial is 1, and 1 here is 1. So now you believe me, 0 factorial is 1, right? Okay, so let's simplify this expression here. So we'll have n factorial over n factorial, which would be 1. Okay, this 0 factorial was 1. So we can write the first term as simply a to the power of n. Was n choose 1. So going through the motions again, we can write n, expand that bracket as this fraction, and we can write n factorial as n times n minus 1 factorial. So this term and this term will cancel away, or you can look at it like so. So we'll have simply n. So we'll simplify the second term just to n times those two coefficients, those two terms. So n choose 2. Let's simplify n choose 2. going through the motions, we can write top of the fraction as n times n minus 1 times n minus 2 factorial, so that we can cross off these two similar terms together. So in general, you need to remember this form, that n choose 2 is n times n minus 1 over 2 factorial, and so on. Let's look at the third coefficient. So we'll see that the numerator can be written like so, so that the n minus 3 factorial in the numerator and denominator cancel each other out. So are you understanding the pattern? The next term would be calculated similarly. We would have n times n minus 1 on top of the fraction, and n minus 2 and n minus 3 on top of the fraction. N minus 4 factorial would cancel away with the denominator, and so on. So I hope you are starting to get the pattern here and understand how it's come about. Alright, so we know that n choose n will be 1 as well. Okay, so we need to understand and remember these forms, because we need to use the cancellations, because our calculator will not help us calculate these values. Alright, so I know this is preliminary example. Yes, your calculator can help you solve this problem very quickly, but we're going to go through the motions so you learn the pattern. So we always write the general form of this expansion here. And notice these blue numbers are exactly what came from the last slide, so try to remember them. All you have to do is substitute n is 4 and x is simply x. Alright, so we'll get such expansion, putting those, well, multiplying 3 by 4 by 3 and so on isn't that hard. So you'll get this, and you notice that this is finite and exact. Every term in this expansion could have been done on the calculator, but we're learning the pattern. Alright, in this case, once again, you've been asked to calculate everything. So just writing the general form of the expansion and substituting n is 3 and x is minus 2x. So what I mean is that this bracket here, make sure you substitute minus 2 inside the bracket for when you're squaring and you're cubing, and this bracket also. So don't miss out the minus 2 with the x. Most students forget that to use a bracket here, and they lose a lot of marks and everything will go wrong. So always use a bracket when you're squaring and cubing in particular. Alright, so this working out, this example will turn out to give you these numbers. Alright. What we're saying is that we don't need to go any further than x to the power of 3. So let's look at this example. We've been asked to expand or use binomial expansion of 1 over 1 plus x. You might think to yourself, this is not a binomial. What are they asking us? Well, you have to make it a binomial by rewriting this fraction with a power. So what's the power of this bracket here, 1 plus x in the denominator? Alright, have you got it? It's 1 plus x to the power of minus 1. So now you see here the power is minus 1, and your calculator wouldn't help you calculate binomial coefficients where n is negative. So you're going to have to use these expansions and go from the scratch. That is working out, that we figured out. These terms here are expansion of n choose 3. Okay, so now that you know the general form, you're going to substitute minus 1 for n and x is simply x in our case. We don't have a coefficient for x, so that's lucky. When we write it out, we'll have minus 1 times minus 2. You understand? Because we had minus 1 minus another 1. That's where this minus 2 came from. And the next term would be minus 1 times minus 2 times minus 3, and so on. Alright, so let's look at example number 2. This expansion is infinite, and we actually will be asked to say for what values of x this expansion is valid. Let's look at it in the next example. So, in this question, we've been asked to find binomial expansion of 1 minus x raised to the power of third, and also state that for what values of x if this expansion is valid, because it wouldn't work for any value of x. I'll show you why. So, we write the general format of the answer. This is the general format of 1 plus x expanded, but we have n to be a fraction, and x is actually a minus x. It has a coefficient, so that's why it's important to use bracket here. So you'll get these terms. N is a third, so a third minus 1 is negative 2/3, and negative 2/3 minus 1 is negative 5/3. So it involves you thinking about the fractions carefully. 1/3 minus 1 means 1/3 minus 3/3. Alright, that's how you get negative 2/3. And negative 2/3 minus 1 means minus 3/3. Alright, so that's how you get negative 5/3. Okay, so then we just have to be careful with the negative signs and make sure your x's here get a coefficient of minus 1 when you square and cube them. So that means that here this x will be turning to positive, but this x will remain negative when it's cubed. Alright, so now for what values of x will this expansion be valid? We said this expansion is actually infinite because it can go on. The powers uh, don't help us put a dot. These to simplify these, we need to know that for what values of x it will converge. So if x is a positive 2, this these fractions will be converging. All right. So we get smaller and smaller values. Right. So this this series is actually an infinite series. So as you see here, powers of x will be increasing. We've got x cubed, and then we'll have this bracket raised to the power of 4, and so on. So what you need to consider is what you're putting for value of x is negative x. The sign actually doesn't matter. The absolute value of x, because that's what goes inside the bracket for whatever coefficient that it comes with. Here the coefficient is 1, has to be less than 1. Okay, why does it have to be less than 1? Because if you remember when we looked at the infinite series, when we had geometric series, and we said sum to infinity will be valid when r is absolute value of r is less than 1. The same situation's going on here. Alright, so because we will have infinitely many x's, the absolute value of x has to be less than 1. Alright, so what I'm saying is that if you had 1 minus 3x here raised to some power, doesn't matter what power, you would take minus 3x. You take the absolute value and you say this has to be 1. What does that mean for x? It means that 3x has to be less than 1, or actually it should be bounded between these two values. So therefore x has to be less than 1/3 or bigger than negative 1/3. That means that absolute value of x has to be less than 1/3. Okay, so this line here has the same meaning as that, the line above it. Alright, so we'll see more examples of validation of the series in more depth. So let's see the next example. Alright, so in this example, we've been told to simplify 1 over 1 plus 4x raised to the power of 2 and state the values of x for which this expansion will be valid. So we rewrite this fraction as one bracket with the power of negative 2 rather than positive 2 in the denominator, like so. So now we can get to work and use the general form of binomial expansion. This form I've put on top of the page, but you should really remember it. So this is the general form of the expansion. What is our n? Our n is negative 2, and x is going to be replaced with 4x. So this 4 is positive, so that's fine. We replace it with 4x. Let's see what happens. So when you perform the substitution, you'll end up with these numbers. N is minus 2, so minus 2 minus 1, minus 2 minus minus 1, so minus 4. So now then we have to perform 4 squared and 4 cubed. So don't forget the 4 is raised with the power of x as well. After some simplification, these are the terms that you get. We only need to go to the power of 3. Now, to consider for what values of x it will be valid, we said this is going to be an infinite series, really. We're not writing every term, are we? So, what's raised to the power of 3 here will be raised to the a larger power. So, it has to converge when absolute value of 4x is less than 1. So, that means that we can write that inequality as 4x has to be either less than 1 or bigger than minus 1. We divide both sides of this inequality by 4, so we'll have a quarter on the left and right, well, with a negative quarter on the left. Therefore, absolute value of x has to be less than a quarter. These two lines are exactly the same. So that's the validation of this series. Alright, so I'll show you another example. In this example, we have to calculate square root of 1 minus 2x and use the binomial expansion, and then use it with the answer of x being equals to 0.01 to figure out what's the square root of 2. So before we can tackle the later part of the problem, we just need to use our binomial expansion. What's this square root written as a power, with powers? We can write 1 minus 2x in a bracket and put power of what? Power of a half. That's it. Alright, so first of all, we're going to use the general form of the binomial expansion, and then we will substitute correct values of n and x into that. N came from here, that's our n, and x has to be replaced with negative 2x. Alright, so let's see. After some working out and after some expansion and simplification, we'll end up with these answers here. Alright, so what do we do then? Why? How do we use the fact that How do we use uh, 1 minus 2x raised to the power of half to answer our problem? Well, what's the similarity between this square root and square root of 2? If you think about it, write it like so. How can these two be the same? So just solve this equation. Square both sides. That means 1 minus 2x has to be equal to 2. That means that I can write 1 minus 2 equals to 2x. So then what's 1 minus 2? Minus 1. And x has to be a half here. Right, I went ahead and substituted minus 1 1/2 for x into our expression. That gave us an approximation of 1.437. Now, that's not an accurate approximation, but it's fairly close to 1.42, which is the correct answer. Now, the question did tell us to use this fact that x is equals to 0.01, and I didn't read that carefully. So let's use that substitution for x to see what values we'll get. Once you substitute x equals to 0.01, under the square root on the left here, you'll have 1 minus 2 times 0.01. Okay, so that's where the 0.98 comes from. So on the right side, you'll get these values when you put it in your calculator. Then if you just add up these values to the right, you'll get a number, and you rewrite 98 as 98 over 100. Alright, so if you square both sides at this moment, you get 98 over 100, which can be written as 7 root 2 over 10. Multiply both sides by 10 and divide by 7. You get your answer for approximation of square root of 2. Square root of 2 is fairly close to 1.4142. Alright, so let's see the next example here. By the way, this approximation is not asked us, the question didn't ask us to prove for which values it's valid, but it has to be valid when absolute value of 2x is less than 1. So that means absolute value of x has to be less than a half. Alright, so that's why this didn't work out quite well. This substitution of half actually is not valid because it doesn't converge. It has to be strictly less than a half. Alright, so in this next example, we've been told that f of x has this format. It's a fraction, with 2x in the numerator, 2 plus x in the numerator, and a square root of 1 plus 5x. So we've been asked just to figure out the coefficient of x squared in this expansion, and in part we state the range of the values for x, which will give us a valid answer. So how do we deal with this problem? You can write this as 2 plus x multiplied by 1 plus 5x raised to the power of negative half. Alright, so we leave 2 plus x alone because that doesn't have any powers on it. We just leave it for the last step of our calculation. We just need to make sure everything's multiplied by, or rather most of all the answers that involve x squared will come from 2 plus x multiplied by our binomial expansion. So let's expand this binomial expansion. The general format is like so, and we substitute our values of n and x. N is negative half and x is 5x. So we're going to replace all the x's in this formula with 5x and all the n's with a negative half. What we end up with is these values here. Now, once you put the numbers in your calculator, you'll get these answers. Alright, now is the time to do some multiplication and see which of these values will give us x squared. Right? So once you write out the expansion form, what you notice is that this term multiplied by this term will give us a square, x squared, and 2 multiplied by this term here will give us yet another x squared, which their coefficients need to be added with each other. So minus 5 over 2 needs to be added with 2 lots of 75 over 8. When you add the coefficients, alright, you get 75 over 4 and negative 5 over 2. When you add them together, you'll end up with 65 over 4. Okay, so we've answered part A of this question. Let's look at part B. Over in the top right corner, we know that 5x here, its absolute value has to be less than 1. What does that mean? It means that 5x has to be between 1 and minus 1. And when you divide by 5, you get x has to be less than 1/5 or bigger than negative 1/5. And you can write that as absolute value of x has to be less than 1/5, like so. Alright, so let's look at another example. This is the last example. We've been asked to calculate 1 plus kx raised to the power of 4 and and we've been told actually that the coefficient of x squared is 90, where k is a positive value. So in our calculation, we will have to set the abstract value for the coefficient to 90, coefficient of x squared to 90, and solve backwards for k. So we are basically looking at this term here in our expansion. So there is no need to write every other term in our expansion. When we look at that term here, we'll have n times n minus 1 x squared over 2. 2 factorial is 2. Now, what's the value of n in our case? N is a minus 4, and kx has to be replacing the x over here. So when x is raised to the power of 2, k has to be raised to the power of 2 as well. And what we'll get is minus 4 times minus 5 over 2. So that's minus 20 over 2, which is a minus 10. So what we've been told is that the coefficient of x squared, that is negative 10, sorry, that's a positive 10, positive 10 k squared is 90. Solve for k. Divide both sides by 10. K squared is 9, and therefore k is 3. Now we've been told that this k is positive, so we're going to ignore the fact that it could have been minus 3. So now that we know value of k is 3, we are asked to find the corresponding coefficient of x squared. So that means going back to this expression here and substituting 3 back My apologies. There was a mistake in the question, so I actually had to change this to x cubed rather than x squared because we already knew the coefficient of x squared in part A anyway. So what's the coefficient of x cubed? X cubed, we can look at it, look at the work, this term here, and we need to basically calculate that. What's n times n minus 1 times n minus 2 times k, which is 3x raised to the power 3 over 3 factorial. Well, when n is 4, we'll have minus 4 times minus 5 times minus 6. And 3 cubed is 27. And we'll have 3 factorial. 3 factorial is a 6. So this 6 will cancel away that 6, but leave a minus 1 behind. So we'll have negative 20 times negative 1, which gives 20. So 20 times 27 x cubed. So that's 540. Yeah, the coefficient of x cubed is 540, and that's the answer to the last part of the question. I'll see you in the next video.